No USB, it's got written on it, so I suppose we better check. I've got to be honest, this has been sitting around for a few days. I've been a bit lazy. Well, I haven't been lazy, I've just been busy. Been out working with my band, playing lots of loud music. Right, let's see what we got. That makes a nice little beep. So then, let's see if we've got anything on the USB supply. Oh, well, we've got a boot screen. Right, let's have a look. Not a thing. That should actually don't particularly want that doing. I should have an LED lit up on here, and we haven't, so we've got no USB 5V. No workies on the buttons, so yeah, there's no USB. Rightio then, let's get this baby apart. Now, the wonder of technology. Took it apart in a flash. Right, well, I think what we need to do, as in the USB 3 or the hub, is just under here. So what we're going to have to do is remove the top plate, but what I should do is replace it with a different top plate that's got the cutout. That way I can stop them from getting too hot. Alright, sorry for the break, guys. I had to go and attend to something. Right, where did we get to? Right, okay, yeah. I've ripped the bottom off and I've changed the bottom. That was the one that's on here, so you can see what I've actually done. Cut out a couple of holes. That was actually for another project. That's when I did the UART mod. But the reason why I've done that with the plate is because I do quite a lot of work with the UART, so it's running quite a lot of the time, and the thing does tend to get a bit warm, so it was easy to just cut the plate. And then when this problem cropped up, I was trying to look at the chip, and of course it kept getting hot, so I cut a hole out for that, and that's where we are. That was on not this particular one, but one I had a fair while ago. And I'm assuming this is probably a similar issue because the fault's exactly the same. Right, we're going to nip over to the microscope. We've got 5 L's bells. Yeah, that's well down. Should be 3.3 volt, and then that should also be 3.3 volt, which it isn't. This is not looking good for the chip. Now, my scope's gone to sleep. How do I wake it up? Push that button maybe. There we go. Okay, scope's awake. Yeah, you can see that. Right, what did I say? I forgot what pins I said in here. Oh dear. I think it was 5, was it? No. 6 and 7. I believe it was a crystal. Let's have a little nosy. 5, 6 and 7. Yeah, X1, X2. Yeah, 6 and 7. So we go back to that. There you go. Right, let's see what we can find. Okay. Got to move the thing again. There's the crystal, so yeah, we're not too far out. We should be able to read it on the rock actually. So we'll see what we've got in this old rock here. Let's just set that up a minute. Okay, right. Well, we've got supply voltage, or a voltage. And we've got no clock. There's certainly nothing there worth having. So we want to come down. So there's the other pin. So one pin's there. T'other. Oops, come on baby, is there. Definitely we got issues with the chip. There's no clock on either. The other thing it could be, of course, is the power good, but we know that is good because it's booted, and the power good signal, I'll just check that. Where are we? Right, I'm just going to check another waveform, see if that's there. 66, I believe. Yeah, I'm just trying to think which pin it is. If it's 88 pins, only is that side? 22. So that'd be 22, 44, 66 would be that one. So that'd be the M pin on the top. Okay. More reckoning, I should be up top here somewhere. Oh, that's absolutely nothing. I think that's actually on the wrong pin. Yeah, that's better. Okay, VPP, what we got there? 6. Hang on. Oh, auto. Not a great deal. And I'll. Oh, we're going off the screen. What are we on? 1 volt. So we've got about just over a volt, which is an enable. It's a high, so that is good. So the actual enable's there. Right, well I think the only option I've got here is to hop this chip out and pop another one in. Now the thing is, you got to watch with these come in different versions. Right, and what I'm going to do from here, I'm going to strip this down. A bit of IPA. bottle doesn't like to give it up very easy. There we go. Well, there certainly wasn't a lot on there, was there? I see some rust around here actually. I'd like to have a closer look at that. That's well, the battery sixes are all. I was going to say, that only normally happens if the battery starts oozing. This one, it doesn't look like ours. Right, let's just get some of this off, because if you don't, you know what it does. It goes everywhere. Some brakes in it, so you're not sitting around waiting for me to do stuff. Like go and have a cup of coffee and eat the dinner, then come back, you know. I'm only kidding. Right, let's have a look and see. There's definitely nothing on that side of the board. There shouldn't be. Right, okay, I'm overdubbing this audio now because this has been done over several weeks, this video. I decided to replace this chip, which is what I'm doing at the moment. That's the GL3520. Although I don't honestly think it's faulty, because I compared the chip off the board when I took it off to another chip with diode mode, and they read identical, so I'm pretty certain it's got nothing to do with the chip. But so what's happened in the meantime as well is as I said, I stripped another PS4 board down as a sacrificial board to trace where all the print and the tracks went. So after spending a couple of days doing that, everything changed, because we then worked out what was going on. Basically, this chip is in the South Bridge. There's a couple of USB hubs that feed various things. The Bluetooth fed from the South Bridge. That's why sometimes if you could get the thing to connect to your controller, it would work, but very rarely. And then the other output connects to the this chip on the PCIe on the bus, and sees it as a hub. Now that's not been seen either. So during all this, we put this chip back on. I did then remove the NOR off this board, and I processed it, as in read the NOR and then set the bit for the UART. I then connected the UART, and from that we could actually see the problem. What was happening is, as it booted up, with that 3 volt missing, what I did find the device, which is on the other side of the board. I'll show you in a little while. Removed it, and with it removed, the boot, as it booted up, it does report that there's an error on the UART. Then what I did is I injected 3.3 volts into where the supply goes into the chip here, and sure enough, it all comes back to life, and it shows you the 3.3 volts there. I will take you into that a little bit further down the line. Let's shut that down for a second. Let's pop a drive on. Okay, let's set that on there for a sec. Somewhere a bit smaller, a bit bigger. That's going to be, that might fit. We've got PlayStation logo, but I don't know if it's going to boot. I don't think we're getting the USB still. because the LED's not coming on my little test board. We've got welcome back to PlayStation. Yeah, I don't think that's booted. Sorry, I don't think that's working. No, it's asking to push, it's not responding, so it's still not working. Okay, let's just see what we got on the chip. Okay, right, we're back on the voiceover again. So as you see, you replaced the chip, and that's what we're looking at here. There was still made no difference at all, which I sort of expected, to be honest. So from here, what I did, this is now after we've traced where the supply came from. So what I'm going to do is going to edit this to take you to that, and then try and show you how we proved the problem using the UART. Right, from the picture, as you can see, it has dramatically changed. What I had to do in the end was to modify a complete chassis, thanks to Phil. And what I've ended up with is a top and bottom plate that exposes all the board, so we can actually make measurements and see what's going on. You can see to the right the red lead, that is actually UART connected. Where my finger just pointed there is roughly where the chip was faulty. It's a little chip that I'm pointing to. It's not actually on the board, and what I'm doing here is, you see this red clip, there, the red clip there, that is what's supplying the 3 volt to where that chip is missing, what I'm pointing to, and it actually all worked fine. And what we got come back from the UART was that the device was there and it was all good. And what I've actually been able to do at this point was to switch this supply on and off and boot each time, and each time I did, it would say it was either disconnected, not there, or it was there. So the actual UART, effectively, it does work for diagnostic. It works very well indeed. So what I'm going to try and do is to cut into some pictures and some bits that I managed to capture, and we'll pop them up and we'll take a look at those, and you can see for yourself. Right. This first image, this is, unfortunately, it won't let me stream because I'm actually editing. I can't actually create a stream from the capture device. It's been a bit of a pain. So what I've had to do is capture and then cut and paste into an image. If you look on here, USB bus 0, UGen 0.2 and UART 0, they're just not there, basically. You just can't find them. It's because it's not working at all. Then after the repair, which was replacing that 3.3 volt switch, you'll see in a moment, it will come up and you'll see it even names the chip. There you go, Genesis Logic, which is what it is, and it's found 2 removable self-powered ports, and of course that's the front 2 USB ports, and it works fine. If I scan it with the controller plugged in, it will also tell you the controller details. Same as if I plug a USB memory stick in, it tells you all what that is. So if I plug the USB stick in and boot it and capture the log, you can actually see the stick that it's found and all the details. And there we go from there. So that's really about it in a nutshell, I would say. Okay, I have added the logs as they as I videoed it as they was being used, but unfortunately I don't think you're going to be able to read these. The image quality is not great for some reason, because you can't scroll back on them, so there you go. But yeah, it just goes to show that the UART method does really work, and as I say, it certainly helped in finding this problem. As I say, it was quite a strange one because of the way it sort of the chip was partly working and partly not, and the reason for that, I think, is because there was a very low voltage on its input, but I don't think it was enough to sort of work properly. But sometimes when you'd boot up, it would recognise a port, but it wouldn't recognise the actual the chip. But yeah, anyway, so as I say, it's I think if you get a no USB, first thing to check is to check pins 85 and make sure you've got 3.3 volt, 85, 86 and 83 I think. There is a cheat sheet on one of my videos of the GL 3220 with the voltages on it, and if that voltage is missing and the device is not reading sure, if you're reading about 0.4 diode on it, then you need to whip the board out, flip it over, and right at the back of the board you'll find there's 3 chips together, and one of them is the this little character. It's little SOT235. It's 5 pin. It's the only one there. And just check on its top right hand pin. As you look at the board, it'll go to a copper pad test point and just measure it. You should have 5 volt on pin 1, nothing on pin 2, that's ground. Pin 3 normally got 3 volt enable, that's switching in. That's where you must have 3 volt because that turns the device on. And then I think pin 1 is your output, and pin 4 I don't think it's connected. There you go. That's really it. It was a bit of a swine, and as I say, sorry the video was a bit chopped about. I was rather hoping I could show you a bit more, but unfortunately a lot of the video that I took of doing all the mods to the chassis so I could run it as you saw it, the videos didn't come out, but I'll try and get a bit of video of the board showing you what I did to it and add that on here in a minute. So hang on a minute, I'll be back soon. Right guys, what I'm going to try and do, it's been such a long shot with this problem with this thing, waiting for bits and everything else, that the video is so disjointed that it's making it rather difficult to edit. So I'm going to record a section. What we've got in front of us, this board, as you've previously seen, I'll just quickly go through this bit, had no USB whatsoever. Changed the Genesis chip, which you see in the previous part of the video, didn't make any difference. Got an old board and de-stripped it, just started plotting out all the copper to see where the connections went, and it turns out the actual device that supplies the 3 volt switching is this little tiny package here, and basically it just gone open circuit. It just wasn't switching. So I can get you a close-up, I'm going to have to just move the camera a fraction, so just bear with me a second. Position, PTZ, what do we want to go that way? There we go, that's better. You can see that now. So the culprit is this little blighter here. Now the thing is, what makes it awkward is about, I think 3 or 4 people I contacted and said, what is it? Have you got a number on it? And every single one was different. So it was just, you know, hopeless. So looking at the pin out, the top pin on the right, pin 1 is 5 volt, the second pin in was ground, bottom pin was standby, so, or enable, top pin on the right, which is pin 5, is it 5? Yeah, 5 was output, and then pin 4 down here on this particular chip is not connected. So from working the pins backwards, it was reasonably obvious that it was a regulator, a low dropout. So I just put a standard T something 3 in, and consequently it all come back to life. But the weirdest thing about it was the other chip hadn't totally gone. It was leaking 2.0 volts across to the Genesis chip, which was enough to make it partially read when you run the UART, but not enough for it to actually read data. Now the 5 volt on the port has got nothing to do with that chip at all. It has in the way that it turns it on, but the 5 volt doesn't come from the Genesis chip. It actually comes from this 5 volt regulator, and it comes from these 2 chips here. There's one and one there. And what happens is the Genesis chip will switch these on via this here, so that the 5 volt comes on. Now that was also a problem. You wasn't getting any 5 volt coming on, obviously, because the Genesis chip wasn't working. So what I'm going to do now, I'm going to take you over to, if I can find the, there we go. At the moment it's just picking up random dribble. So what I'm going to do is boot it, and if you record this, I'm hoping that when you go back through it rather slowly, you will find it will mention UGUN0, which is the address for the Genesis. You'll see that it mentions the Genesis chip and it's working, and it should find I've got a Kingston USB stick plugged in, so it should find that as well. So that will give you some idea. Plus the fact I'm going to power it on from the controller, as you heard, and there we go. So as I say, it's all now working. So this scan is of a working one. The scan that I've just posted those 2 little short parts up from, if you look at the beginning to find out what the abbreviation to the line is, then you can look it up on here. So we'll let that go. Right, it's now booted to user, so the data will be in that lot somewhere, and I'm now going to shut this down. Okay, that's now shutting down. So the whole shutdown sequence is there. It doesn't matter what you can read off of this one. This board's now my board, so they don't really matter. Right, so there we go, shut down. Now let's go back to the pick keys. Right, now I had a few mentions from a few friends about what I've done to the board, so I'll just show you, explain. There's a mains motor here, which is out of shot. Let me just try and pop up a bit higher. There you go. That's just a mains fan that's blowing. What I've actually done is that there, I think if I take the power supply off, you'll get a better idea. Let's take the HDMI out. and power supply off. Okay. There we go. Power supply up the way. Right, there you can see all that's left of the top board. It is enough to run it. I only had a couple of red warnings. That was before I put a fan on it. I'm using a mains driven fan. You can use 12 volt. So all I've done on this, it's not even warm, it's fine. There's your NOR. I've had that off as well. In fact, there's a video before this, which is this NOR that I showed you how to program. Where was I? Oh yeah. What I did was put 3mm pads under the on the what do you call it, the RAM, and then on the other side, so I still got really got a hard drive hanging by its thingy. Let me just put this over. Well, that's the connection. There's the UART, and this is the other side. And basically, again, it's just a section cut out. I've had to fold these edges up to give what was left of the board some rigidity. If I tilt it up, you might see in there, down there, I take some light back there, will you? You should just see the pads. There you go, blue pads. That was more than enough to keep the baby cool. That is the chip, the Genesis chip there, under here, that one. Now that red lead, let me just pop in a bit of a close up. Oh. Come on, focus baby. There we go. Right, that red lead, that is actually on the 3.3 volt pin 80. I can't remember if it's 86 or 85, you know, I'd have to have a look. That's where I was injecting the 3.3 volt initially, when I was sort of looking for the fault. As far as I can see, that 3.3 volt only feeds the Genesis, and also I think maybe, let's just get that out of the way. I'm not sure if I'm going to get all that in. There we go. Let's just move this fan. I'm going to stick my fingers in it. Yeah, and then possibly there is a feed. It actually goes off over here somewhere, but down here. Sorry, where are you? There you go. But it's not the 5 volt feed to the USB port switches. These are the 5 volt switches, just for the 5 volt output. They are switched by the Genesis as well. But the supply for that is not the supply for that, although it does come over here somewhere. But I just couldn't be bothered going further. So that's it really, in a nutshell. There you go, so you see it all. If you get one with no USB, don't jump to the an OG. Don't jump to the conclusion it's the Southbridge. It not necessarily is. If it's Southbridge, the Bluetooth USB won't work. Whereas the as I say, the Southbridge, if it's working, the controller. It's an awkward one. How can I put this? Once you connect the controller via USB, then the controller talks on USB, but not the front ones here. It'll go through the Bluetooth and via the controller in the Southbridge. If you've only got cable with no Bluetooth or no battery, then it'll go through this end, through the Genesis chip. So what you get is a symptom. It will all boot up and it will come up where you can't enter anything. Now, what is a little bit strange is the fact, well, why can't I partner it by using the PS button if it uses the south bridge? The initial push of that PS button has to go through the Genesis chip. That is the issue. And that's what had me going for a while. So there you go. I hope that was reasonably informative. Sorry it's a bit of a mess, but I think it'd be a shame to scrap the video because I think there's a lot of information that could be used. So there you go. Take it on, and I'll catch up with you soon, guys. Bye.